In this video, we will see how to approach low-level design questions. First step is requirement gathering. Start by listing all the features you have identified. These problems usually don't have a clear-cut solution, so ask as many questions as possible to fully understand the requirements. Don't assume anything beforehand and always clarify any assumption you make with the interviewer. Remember, the interviewer is evaluating your ability to collect requirements effectively, so make sure to demonstrate your skills in this area. Also scope the requirements carefully to ensure that you can complete the implementation within the given time frame. Second step is identifying the entities and relationships. In this step, you will list down the objects involved in the system. For example, if you're designing a snake and ladder game, potential objects could include player, board, dice, game, etc. Once you have all your objects, the next step is to determine the attributes and the operations for each object. Every object has properties and methods that allow it to fulfill its role in the system. Recognizing this can help you create your classes. After identifying the objects involved in the system, you need to understand the interaction between those objects. Define how two or more objects communicate with each other. The objects can be represented and visualized with the help of UML diagrams. Using a class diagram, you can represent the objects and their relationships, helping you to clarify the structure of your system. Third step is coding. In interviews, you will need to code the classes and relationships you identify using a programming language of your choice. The interviewer expects you to create a high-level structure of the system. Start by writing abstract classes and interfaces followed by concrete classes. This approach helps to maintain a clean and organized code base. Besides object-oriented programming skills, it is important to understand and apply solid principles to the problem. This ensures that your code is well-structured, maintainable, and scalable. Always aim to write code with high cohesion and low coupling. This means that each module or class should have a clear purpose and be independent of others as much as possible. Fourth step is design patterns. When applying design patterns, consider the problem you are solving and choose patterns that fit the situation. Remember, you have limited time to code the solution, so prioritize modularity, extensibility, and reusability. Some commonly used patterns include singleton, factory, and strategy. You don't need to memorize the code for these patterns. Instead, focus on understanding their structure and the problems they solve. This will make it easier to apply them effectively to the problem at hand. Is it necessary to use multi-threading? Interviewers often ask candidates to make their design multi-threaded, usually towards the end of the interview. This helps them assess how well you can apply concurrency concepts to a problem. The main purpose of multi-threading is to use resources efficiently. You need to identify how to break your code into independent tasks that can run concurrently. For example, in a chat application, you might have one thread for handling incoming messages while another thread handles outgoing messages. It's a good idea to review concurrency concepts before your interview to ensure you are prepared. Note, it is not mandatory to draw use case, activity, and sequence diagrams. It all depends on your interviewer. So, if your interviewer asks you to draw them, then do so. Thanks for watching. Don't forget to like and subscribe for more programming insights.